In traditional Indian culture, the major rivers are worshipped as gentle, life-giving mothers, but the Brahmaputra is the glaring exception. It is the only major river in the region revered as a male entity. While most rivers passively carve out valleys over millennia, this water acts like a liquid wrecking ball, physically tearing massive chunks of the landscape apart in real time. In Assam, the water frequently turns a thick, rusty crimson. Local legends describe it as the river bleeding out of anger. Geologists look at the exact same crimson water and see millions of tons of upstream soil, a definitive warning sign of impending disaster. When the summer monsoon hits, the channel swells beyond its banks, submerging entire villages and stranding millions of people and livestock in vast inland seas. To understand why this channel acts as a weapon of mass destruction, we have to stop looking at it as a localized flood. We have to track the water backward, tracing its extreme geographical descent from the roof of the world. High up in the frozen, arid extremes of Tibet, the water begins its journey at the Yangtze Glacier. Up here, it goes by the name Yarlung Tsangpo. For 1,200 kilometers, it behaves like a docile traveler. It wanders eastward across the flat Tibetan plateau, flowing parallel to the Himalayas instead of cutting south toward the ocean. Eventually, the water hits a colossal wall of rock. The snow-capped peak of Namcha Barwa stands directly in its path, forming an impenetrable physical barrier. This 3D topographical map illustrates what happens next. Instead of pooling, the water executes a sharp U-turn, pivoting tight around the mountain to slice directly through the Himalayas. This maneuver, the Great Bend, initiated a downward plunge, carving a canyon deeper than the Grand Canyon. Thousands of meters of vertical freefall convert the river's mass into pure kinetic energy. By the time it exits the mountains and hits India, the water possesses enough force to chew through solid bedrock. Crossing into Arunachal Pradesh, the channel takes the name Siang. Here, the current moves with such velocity that it scours the bedrock, tossing heavy, gray rocks downstream as if they were pebbles. As the Siang finally breaks out of the mountains and into the flat plains of Assam, it is hit from the east by two other high-velocity Himalayan streams, the Dibang and the Lohit. This profile diagram shows the steep mountain gradient flattening into the valley. The water's velocity drops sharply. Losing carrying capacity, it immediately drops the pulverized rock from the mountains, choking the channel. To bypass this debris, the water splinters into shifting pathways, a braided river system. The 1950 earthquake, registering 8.6 on the Richter scale, physically restructured the entire Assam Valley. As mountainsides collapsed into the channel, the riverbed was forced upward by millions of tons of debris. When the water finally surged through this new rubble, it was forced to flow through a shallower, wider basin that had lost its original depth. A shallow, braided basin packed with shifting silt leaves the heavy monsoon rains nowhere to go. The devastating floods in Assam are simply the mathematical result of a river choking on the remains of the Himalayas. Yet the exact same dirt that buries downstream villages also creates life. The dumped sediment built Majuli, the largest river island on Earth, providing a fertile foundation for entire communities right in the middle of the current. Crossing its final border into Bangladesh, the water changes its name a fourth time to the Jamuna. The flat terrain allows the channel to widen so dramatically that a person standing on one bank cannot see the other. This top-down map reveals the ultimate hydrological collision. The Jamuna flows south, slamming into the Ganges River, arriving from the west. They merge into a single, colossal outflow, known as the Meghna. For millions of years, the Meghna has dumped its massive payload of Himalayan soil straight into the Bay of Bengal. This continuous offloading built the Sundarbans, the largest and most biologically dense tidal delta in the world. The entire system operates as a continental conveyor belt. It grinds down the tallest peaks on the planet, hauls the crushed rock hundreds of miles, and uses it to construct highly fertile land at sea level. We routinely attempt to cage this system. We drive massive concrete pillars into the shifting sand and build endless miles of embankments to lock the water into a predictable path. But every monsoon, the river simply erases our engineering. It overwhelms the levees, drops new sediment, and forcibly drafts an entirely new map. Now, warming ocean temperatures are driving sea levels higher, allowing the Bay of Bengal to push inland and swallow the exact delta this river spent millennia building. From the glaciers of Tibet to the Bay of Bengal, the Brahmaputra continues a process of continental construction that ignores our borders and our concrete. It is a reminder that the geography of the planet is not a finished map, but a work in